everyone. So my name is Krishna Reddy. I'm a professor of civil and environmental engineering at the University of Illinois, Chicago. I want to thank the organizers for inviting me to present in this symposium. So my presentation title is Integrating Artificial Intelligence in Contaminated Site Remediation, and I'm going to focus more on remediation of polluted groundwater. So I'm in charge of these two labs, and we work in our lab on environmental remediation of soils, sediments, groundwater, and stormwater. We also work on waste management and landfill engineering, and we work on life cycle assessment and sustainable and resilient engineering. We work on geotechnical engineering, mainly from a civil infrastructure point of view. So if you are interested in knowing about our research, so please feel to look at these websites. So talking about contaminated sites, there are many sites that are contaminated. Soil and groundwater is contaminated at these sites, and it's invisible, and it's a huge problem. And there are many sources of contamination. I listed many of them, and one of the major sources of contamination is land disposal of solid and liquid waste. And in the US, we have a good estimate on number of sites. We have thousands of sites, and it's going to cost a lot of money to clean up these sites. So we have a similar situation in Europe, and also other developing countries have a lot of these contaminated sites that needs to be cleaned up. So when you talk about contamination, what is contamination, right? What is contamination? You can see, this could be inorganic contaminants, heavy metals, or radionuclides, or organic contaminants like PFAS, which is a very big problem these days. And you have all these other organic compounds, as our previous presenters presented, even microplastics is a big problem. So you could have other issues like pH, nutrients, biological contamination. These are all problems because they pose toxic impacts to humans and also to ecosystem. And when we talk about groundwater is a valuable resource, and we must protect it from contamination because it is the sole source of drinking water for many people all over the world. So in the US, USGS and other agencies have done a good job in terms of identifying aquifers that have been contaminated. So these shows the aquifers that are contaminated across the US. Contamination could be natural geological sources or from human sources. And even in Mexico, it seems the groundwater is contaminated with a lot of these contaminants that exceeding the levels. So we need to clean up groundwater because, contamination from the groundwater could be exposed to people by different exposure pathways, and it could cause unacceptable human health risks, and also risk to surrounding ecology. So there are a lot of technologies to clean up contaminated groundwater. These are a few technologies that we worked in our labs. And if you want to know more about these technologies, you can go to these resources, find more information about them. But the problem is, the selection of the remediation technology depends upon many factors, like a site characteristics, soil characteristics, groundwater characteristics, contaminant characteristics, and what are your remedial goals? What is the cost, financing, time for remediation, and what is the end use of soil or groundwater? So all these factors have to be considered in selecting the remediation technology. And moreover, when you are designing a particular remediation technology, you need to consider site-specific contamination and local geological and hydrogeological conditions. And there could be many variations in selecting the system components. And there are many variables in design and operational parameters. There are many different ways that you can implement this, implement the remediation. And there are many variables in deciding the monitoring requirements. And you want to monitor and also may want to adjust your system. That's optimization. That also depends. And all these aspects add a lot of complexity and additional costs, time, resources. For anybody who is working in remediation field, they know this problem. So this is a huge problem. So in this context, can artificial intelligence help? So in fact, it can. If you look at contaminated site remediation, there are different phases of contaminated remediation projects. And in each phase of these projects, AI could be useful. And there are a lot of AI approaches, models, tools that can be used. And it can be used for spatial distribution of the contamination, to develop the decision support tools, to have a simulation of optimization, or you can have a data-driven modeling. So all these things, have a possibility to achieve. And many of you know artificial intelligence. Basically, it's the theory and development of computer systems that can perform tasks that normally require human intelligence. There are a lot of different types of artificial intelligence methods that can be, or tools that can be used. But most of the times we try to use machine learning and deep learning models. And as you see, these models are evolving at a very, very fast rate. And we have published recently a review paper, and we published a few papers on using AI in our site remediation projects. I recommend you to look at these papers for the background on different AI methods. So I want to show you quickly two case studies on how AI is being helpful in contaminated site remediation projects. So this is the project in California. So they have done extensive groundwater monitoring and testing to look at PFAS concentrations across this California. But you can see that there are areas where information is not available. So this AI-ML model is used to predict the concentrations in the areas where the data is not available, and also use that data to prioritize the locations where they could go and drill wells and monitor. So kind of using the AI as a guiding tool to look at the locations where they can actually go and put in wells. So for the development of this AI model, they used all the existing PFAS concentration data. They also used the nearby airports and also hydrologic features, the 14 of them, and soil features, 16 of them. And they also looked at any kind of correlation between the coexisting contaminants versus there are PFAS. There are many types of PFAS. If there is a correlation, indeed they found some good correlation between some contaminants and the PFAS, as you see from here, and some didn't have any correlation. So they used all this data to develop a AI model, and it has a reasonable correlation. And with that model, they were able to predict PFAS concentrations in the areas that they didn't have the data before. So with this information, so you can actually, select the locations where you want to drill the wells and collect the samples to know, you don't want to depend upon this AI model, but you want to go and do actual sampling. So this AI model is actually helping us to select the rational locations. So instead of, otherwise you would have probably put in 1,000 wells. Instead of that, with this AI model help, you can reduce the number of wells. That can save the time and the cost. So this is an example of how AI could be used in the site characterization. Quickly, I want to show you the second case study. This is a site where groundwater is contaminated by TDS. And the proposed remediation plan is to have a pumping wells and then pump out all the contaminated water and inject treat it, and then inject back into the aquifer again. So the question is, they have these series of wells, that the extraction wells, pumping wells, and the injection wells. The point here is, how much water you need to extract, what pumping rates, what should be the injection rates, right? So that, we can efficiently reduce the concentrations in this aquifer. So here, AI came into use. So they use this, common models, SmartFlow and MD3D, and they consider different scenarios. And they use that data to develop this AI surrogate model. And this AI surrogate model is shown to have good correlation with physics-based model results. And then with that model, AI model, they use this optimization scheme, and they had 9 injection wells, and they were able to recommend the pumping sequences, how much pumping rates and what times in each well they came up with this sequence. So with this optimized sequence, prediction is that, contamination is going to reduce very efficiently in a reasonable time frame. So this again, provided, instead of not knowing how to operate these injection wells and extraction wells, so this AI-based approach, helping to optimize the injection and extraction and injection systems to efficiently, remediate the site. So in closing, I just wanted to show you AI has a great potential for informed decisions at all phases of groundwater remediation. AI-based optimizations can promote improved efficiency, time, and cost savings. However, there are a lot of challenges in terms of using AI, right? So first of all, you need to have some actual data to train the models. And if you have a limited amount of data, then you may be running into overfitting of the models. And the other problem is a lot of professionals who are working in this area, they are not knowledgeable about AI, so they need to be trained. So also, we need to incorporate a lot of field scale remediation data into databases and train the models. And we need, interdisciplinary research and educational activities so that, we can promote a lot of AI use in remediation projects. So I, went through quickly, but, there are a lot of opportunities for collaboration in this area. So if you are interested in working with us, this is our contact information. Feel free to contact us anytime you like. Thank you so much.